Space, the final frontier. Well, kind of. While it's true that the furthest reaches of space will be the finale in human exploration, we're still a long ways off from actually being able to get there. And considering that we still haven't really mastered the exploration of our own planet, the idea of sailing off across the stars seems, well, rather optimistic. That's not to say that it's impossible, just highly unlikely within our lifetimes. But what if we did achieve it? What would the future of space travel look like? A lot of our ideas and concepts of what space travel looks like are influenced by the media that we consume. Sci-fi hits like Star Trek, Mass Effect, Stargate, and various others are sure to get you thinking about it. Some of their depictions hit it right out of the ballpark, and others are so ridiculous and fanciful that even a normal person would look at it and say that's not possible. But still, they get you thinking that it's just right around the corner. But before we get into all of that, I want to cover some information that puts the difficulties that we face into context. For even the most expeditious of human explorers, going beyond Mars is a Herculean task. Space travel is limited by a number of factors, the biggest of which is time. Technically speaking, our level of technology right now would allow us to explore what we conceptualize as the solar system. But it would be a very long endeavor. We're talking missions that would last on the scale of decades just to explore one planet. And even then, that's probably just going to be a surface level exploration at best. Space is absurdly large. We even have a term for it: astronomical. Think of the longest road trip that you've ever been on, or just the furthest that you've traveled in general. That wouldn't even come close to tackling the distance that Apollo 11 went on its flight to the moon and back. When we're talking about distances this large, using miles and kilometers just becomes extremely difficult in normal conversation. So we'll be using a much more simplified measurement. The first of which is the astronomical unit, or AU, which is the distance between the Earth and Sun, at roughly 150 million kilometers, or 93 million miles. Distance isn't really the issue that we face. You could throw a rock, or if you're an egotistical billionaire with more dollars than brains, a car into space, and it will eventually get to where you want it to go. It just takes a really long time. So we have a problem with speed, which is distance over time, and the universe isn't really going to help us with this problem. The speed of light is 186,000 miles per second, or 670 million miles per hour. Consider it the universal speed limit. But even traveling at the speed of light, it would still take 43 minutes to travel from the Sun to Jupiter, which would cover a distance of 5.2 astronomical units. The furthest out that we have currently sent anything from Earth is Voyager 1 at 156.29 AU. And that took us 46 years just to get it that far. It currently travels somewhere around 3-ish AU per year. At 120-ish AU, you're officially in interstellar space. But depending on your definition of the solar system's boundaries, you're still well within it. Using the largest definitions, the outer edge of the solar system is the Oort cloud, which is a collection of icy objects that sit somewhere around 50,000 AU from the sun. At that kind of distance, we're really going to need a new unit of measurement. A light year is the distance an object traveling at the speed of light can travel within a year, which, that sounds pretty standard for it. That is roughly 5.88 trillion miles, or 63,241.1 AU, which brings our solar system to just a little under 2 light years wide. All of this talk about distance was to put this next statement into perspective. Traveling at the speed of light, it would take roughly 2 years for us to go from one end of the solar system to the other, or roughly 1 year to go from Earth and leave the solar system. The fastest speeds that we've ever been able to achieve are with the Parker Solar Probe at 330,000 miles per hour. That's roughly 0.05% the speed of light. Using that speed, it would take us around 2,000 years to reach the edge of the solar system. I'm betting that it's starting to seem a little bit unrealistic at this point, but I did say that it wasn't impossible. So what will we actually need to do to start traveling out amongst the stars? Well, going faster is always an option. Right now, our only real method of getting off the planet is using chemical rockets. But they're incredibly inefficient and can't really provide the sheer amount of energy that we would need to start getting up to speeds. But if we just ignore starting out on the planet altogether, well, then we open up some interesting options. Enter the United States' best friend for overcoming any technological hurdle: the nuclear bomb. Definitely not Japan's first choice, though. All joking aside, nuclear fission outputs a lot of energy. So much so that it was actually once considered as a replacement for chemical rockets in the space program. Using it on the planet, probably not the best idea, for obvious reasons. But in space, well, no one can really hear you complain about it. A number of projects involving nuclear and nuclear-like propulsion systems have been proposed over the past several decades. The one that you may or may not be most familiar with is Project Orion by DARPA. The basic idea is to create a nuclear blast behind the craft in order to propel it forward, which seems like a pretty basic concept if you're asking me. We already do that with chemical rockets anyways. Project Orion calculated that they would probably hit somewhere in the theoretical range of 3% the speed of light, with later evaluations putting that closer to 10%. Any one of those numbers would be a significant jump for us in terms of our speeds and being able to actually get out and about. It would still be in the ballpark of decades, but that beats thousands of years. The timeline gets smaller as we start to consider more exotic forms of energy. Relativistic rockets rely on matter-antimatter explosions rather than nuclear fission. If that just sounded like a bunch of sci-fi mumbo-jumbo to you, then I assure you, it is real. It's probably the most efficient form of energy production possible. Rockets using this method of propulsion have a theoretical speeds of 30% the speed of light all the way up to 80% the speed of light. The major problem with them is production and storage. Contrary to popular belief, we can readily make antimatter. It's just extremely expensive to do so. The cost is so high and the yields are so low that it's just really not a realistic source of fuel to produce. And even if we were able to make it cheaper to produce with higher yields, storing it provides its own challenges because, well, it explodes when it comes into contact with normal matter. If potentially exploding isn't your thing, and let's face it, it's not, then we always have the option of solar sails. They're slower to get up to speed, but they're safer to use. They work just like you would imagine on a sailboat. You have a sail that catches the solar winds to propel it forward. The problem with just using solar sails is that it's limited by the solar winds. No nearby star means that it's not going to gain any more momentum. And if it loses speed in any form or fashion, well, then you have no way to pick back up. But there are ways to augment this. The most practical is to use lasers to increase the amount of energy the sail receives, effectively creating its own artificial solar wind. Theoretically, we can achieve speed somewhere between 10 and 50% the speed of light. The last method that I'm going to talk about is probably the most unrealistic, but it also happens to be my favorite. Take us to warp speed! That is probably one of the most cliched lines in all of sci-fi. But it is theoretically possible. If you're new to sci-fi, allow me to explain what a warp drive is. Effectively, it warps the space around you to propel you forward at speeds faster than light. Well, if that just isn't as clear as mud, I don't know what else is. So let's talk about something that could be a real warp drive. The Alcubierre drive is purely speculative at the moment, and that's because it relies on technologies being developed that are barely even theoretical. It was proposed by Miguel Alcubierre in 1994 and utilizes Einstein's field equations to achieve its propulsion. The basic idea is that it compresses the space in front of you and expands the space behind you, pushing you forward. The proposed speeds that it can achieve doesn't really matter. The Alcubierre drive breaks a lot of the laws of physics, not just the speed of light. The science surrounding it isn't the problem with it, though. It's staying alive while using it. With the way that it works, the amount of radiation produced within the space around the craft would kill anyone within it. And what you would need to fuel the drive just straight up doesn't exist. So, while the idea for it is really cool, and it would be the most efficient way for us to get out and about, it's just not practical to use or develop. This video only really just scratches the surface of space exploration and it doesn't really cover a lot of the issues that we'd have to overcome. But propulsion is the first thing that we need to tackle in order to get the ball rolling. Other issues we may have to consider are food production while in transit, the issue of the lack of gravity, and protection from interstellar radiation. But assuming that we can get all those figured out, then there isn't really anything stopping us from becoming a spacefaring civilization. Other than us. I hope you enjoyed the video. Let me know if there was something that I got wrong, or if there was something you were hoping that I would cover that I willfully neglected to put into the video. At some point in the future, I plan to cover things like the Dyson spheres, moon bases, and, just all those other little things that go into our concept of space travel in the future. Make sure you subscribe to stick around for the next video. I'm sure it's going to be another banger just like this one was. And I'll see you next time.